Hello students, welcome to our channel. In this video, we are going to discuss about Aldol condensation. In our channel, we are providing handwritten notes for every topic which we have explained. And if you want to download handwritten notes for this topic, you just go and check out the description or else comment section where I have given link to download PDF for this topic notes. So now let's move on to the topic. Aldol condensation. In this reaction, two molecules of acetaldehyde undergoes condensation in the presence of sodium hydroxide. So here sodium hydroxide is nothing but a base and which is act as a catalyst here to form aldol as a product. Here aldol means a compound consists of two functional groups. One is aldehyde and the another one is alcohol. So that is the name indicates that aldol. ALD indicates aldehyde group and OL indicates alcohol group. So let us see the reaction now. So acetaldehyde, I am going to taking two molecules of acetaldehyde. So these two molecules of acetaldehyde undergoes condensation in the presence of sodium hydroxide and producing a new compound called aldol. And this aldol is also called as 3-hydroxybutanol. So let us see the mechanism of this reaction. So firstly I am taking sodium hydroxide here. So this sodium hydroxide, we know that it can dissociate into Na plus and OH minus. So this OH minus ion in the first step abstracts a proton. Abstracts a proton from the carbonyl compound, that means aldehyde from the acetaldehyde. So it is abstracting a proton from the alpha carbon. So here the alpha carbon means the carbon which is present beside the functional group. You can see here CHO is a functional group and here CH3 is the alpha carbon. So it is abstracting a proton from the alpha carbon. So when it is abstracting the proton, H2O will be liberated out. Okay, so this OH minus ion abstracts a proton and liberated out as a H2O. And this, when I am shifting this bond to the this side, this hydrogen gets the positive charge and this CH2 gets the negative charge. So in this first step, carbene ion is generated. Okay, now let us see the second step. So in this, we know that already carbene ion is generated in the first step. So I am taking the same carbene ion here and I am attacking this one to the second molecule of acetaldehyde. So here I am taking this acetaldehyde and I am shifting this bond towards the oxygen. Okay. So here you can observe this carbonyl group. I am shifting the bond towards oxygen. Then oxygen gets negative charge and carbon gets positive charge. So now this positively charged carbon is attracted by negatively charged carbene ion. So we already know that carbene ion is having a negative charge. So this negatively charged carbene ion is attacking on this positively charged carbon. So you can see it is forming a bond with this carbon CH2 CHO. Okay, and this hydrogen, so I kept it at a downside. Okay, so now we know there is a generation of negative charge on this oxygen. So this is called alkoxide ion. So in step 2, alkoxide ion is generated. Okay, now I am taking step 3. In step 3, same alkoxide ion I am taking. To this alkoxide ion, I am adding water. So this alkoxide ion have negatively charged oxygen. So it abstracts a proton from the water. Okay, so it abstracts proton from the water and it forming a desirable product that is called aldol. So you can see here O negative is abstracting H plus and forming OH bond. Okay, so this particular compound, if you observe it, it consists of both OH and CHO functional groups. Hence it is called as aldol. So here ALD means aldehyde group and OL means hydroxy group, that is alcohol group. Okay, so this particular compound consists of two functional groups and it is also called as 3-hydroxybutanol. So if I give numbering 1, 2, 3. So third carbon is having OH, that is 3 hydroxy and it is consist of 4 carbons. 1, 2, 3, 4. So it is called as butanol. Here all means aldehyde. So this is all about the mechanism of aldol condensation.